Hello, I am Engineer Hamza. Today I will be talking about why roads fail, exploring pavement design, materials, and maintenance. Here's an overview of what you'll learn. Have you ever wondered why so many roads seem to fall apart so quickly, turning your daily drive into a bumpy obstacle course? This is a problem faced by drivers everywhere, and it's not just about bad asphalt or poor construction. In this video, we'll dig beneath the surface, literally, to uncover the hidden reasons roads fail. You'll learn how pavement design, the choice of materials, and ongoing maintenance all play a crucial role in road durability. We'll explore how weak foundations, poor drainage, and neglect can turn small cracks into giant potholes, and why surface repairs alone are never enough. You'll see how water intrusion, shifting ground, and relentless traffic combine to create a chain reaction of damage, often starting far below what you can see. We'll break down the science behind pavement layers, the importance of a solid base, and how even a tiny gap can start a chain reaction of failure. Think of a road like a layered cake. If the foundation is weak, the whole structure is at risk, no matter how perfect the surface looks. We'll also look at how surface cracks are just symptoms of deeper issues, and why lasting repairs require addressing the root causes. By the end of this video, you'll understand the full story behind road failures, from the hidden drama beneath the pavement to the visible signs of distress on the surface. You'll discover how traffic, weather, and nature all play a part, and what engineers can do to build smarter, longer-lasting roads. We'll reveal how nature exploits every weakness, and why maintenance is just as important as initial construction. So, if you want to know what really causes roads to fail, and how we can prevent these problems, stay tuned as we break down the science, engineering, and solutions behind every road you drive. Let's get started and uncover the secrets to building roads that last. In engineering, a structure is only as strong as its weakest part, and for roads that's usually the ground beneath. You can use the toughest asphalt, but if the subgrade is weak, the road will fail. The subgrade, rock, clay, or sand, must support everything above. If it's soft, the whole road flexes and cracks under traffic. That's why soil testing is crucial before construction begins. Strong subgrade? You can use thinner, cheaper layers. Weak subgrade? You need a much stronger, costlier design. Ignore this, and you're building a Formula One car on bicycle wheels. Cracks following lorry wheels. That's the foundation giving way. The pavement can't save a road built on a bad base. The foundation is everything. Water is the #1 enemy of roads. Even the best design fails if water gets in. Wet subgrade soils, especially clays, lose strength and turn to mush. Imagine a dry biscuit, strong until it's dipped in tea. That's what water does to soil. Drainage is the most important and most neglected part of road design. Good drainage means cambered surfaces, gutters, and hidden subsurface drains. Blocked drains let water rise, saturating the subgrade and starting the countdown to failure. Many engineers obsess over pavement thickness but forget drainage. A thinner, well-drained road outlasts a thick, poorly drained one. Water always finds a way in if you don't give it a way out. Drainage is the real defense. Bitumen, the glue in asphalt, has a split personality. It's strong and flexible, but its behavior changes with temperature. In summer, bitumen softens. Heavy trucks create ruts as the surface flows. In winter, it becomes brittle and cracks under stress. The challenge? Choosing a bitumen grade that handles both extremes. In places with wild temperature swings, this is tough. Polymer-modified bitumens help, but the problem never fully goes away. The very material that holds roads together also makes them vulnerable to weather. Rutting in heat, cracking in cold, bitumen's strengths are also its weaknesses. Road designers must balance flexibility and strength for local climates. The weather always has the final say. Bitumen is both hero and villain. Even the best design fails if the road isn't built right. Compaction, squeezing the layers tight, is critical. Loose materials leave air pockets, making the road weak and spongy. Under traffic, these voids collapse, causing ruts and uneven surfaces. Worse, air pockets let water in, speeding up failure. Well-compacted layers are dense, strong, and keep water out. That's why you see heavy rollers on construction sites. They're not just flattening, they're building strength. Engineers check density to ensure every layer meets the standard. Rushing compaction or using the wrong equipment builds in hidden weaknesses. A road might look fine at first, but poor compaction guarantees early failure. Good compaction is non-negotiable. Most road failures aren't due to lack of knowledge, they're failures of execution. The science is solid, but it's often ignored in practice. Many engineers obsess over pavement thickness, missing the bigger picture. The real issues are poor foundations and neglected drainage. Drainage is treated as an afterthought, not a core structural element. The result? Roads that look good on paper, but fail in reality. A clever engineer focuses on the whole system, not just the layers. The fundamentals, good base, compaction, and drainage, are what matter most. That's where real engineering happens. In engineering, it's not enough to simply provide an answer. You must be able to justify it with clear reasoning and evidence. Every decision you make, every recommendation you give, should be backed up by solid logic and a deep understanding of the problem at hand. This is what sets apart a true engineer from someone who just guesses or follows instructions blindly. Don't just say, make the asphalt thicker. Instead, explain why increasing the thickness will improve the pavement's durability, how it distributes loads more effectively, and what evidence supports your recommendation. Show that you understand the mechanics behind your suggestion. Good engineers take the time to diagnose the real problem, analyze the situation, and then clearly explain their reasoning. They don't settle for surface-level fixes or vague answers. For rutting, don't just specify a stiffer bitumen. Explain how a stiffer binder resists deformation under high temperatures and heavy loads, and why that matters for the specific climate and traffic conditions of your project. For drainage, don't just say, install a drain. Identify where the water is coming from, how it affects the pavement structure, and design a solution that addresses the actual source of the problem, not just the symptoms you see on the surface. The best engineers dig deeper to solve the root cause, not just the symptom. They investigate the underlying issues, like weak subgrade, poor materials, or inadequate compaction, that lead to visible failures. They see the entire chain of events behind every failure, connecting the dots from initial design choices to long-term performance and eventual breakdown. A pothole isn't just a hole in the road, it's evidence of deeper issues like water infiltration, neglected maintenance, or even fundamental design flaws. Each symptom tells a story if you know how to read it. Real solutions address the underlying cause, not just the surface appearance. That's how you create lasting repairs and prevent future failures. Always show you're working. Use calculations, sketches, and clear explanations to prove you understand not just what to do, but why it works. That's what separates great engineers from the rest. Justify every answer, and you'll earn the trust and respect of your peers, your clients, and the communities you serve. Good road engineering is about predicting how materials will behave under stress and moisture. It's about seeing beyond the plans, anticipating how the road might fail. Engineers ask, will the bitumen rut in summer, crack in winter? Will water find a way in? The goal isn't just to build a road, but to build one that won't fail. That means designing for problems before they happen. Pay attention to drains, compaction, and climate. A road is always fighting traffic and the environment. Success depends on understanding that battle and respecting the materials. When you get it right, you build infrastructure that lasts decades. That's engineering at its best.